We're going to cover 3 more RxJS operators in this video: map, filter, and merge. So if you don't know what we are doing here or why we are in Factorio right now, you might want to check out the last video. But the basic idea is we are using Factorio as an analogy for how RxJS streams work. So the analogies often aren't perfect, but they can help illustrate some ideas in a visual way. So a bit of housekeeping from the last video, I've changed the analogies we're using here a little bit. So before I had these little robot picker arms picking items off of a stream or a conveyor belt here to represent a subscribe, and it would just put that into a box. But a commenter pointed out that a problem with this analogy is that a subscriber is passive. So it isn't pulling data off of a stream. All the data in the stream is being pushed into it. So to put it another way, if I were to puncture a hole in a pressurized water pipe, I don't get to take water out of the pipe at my own leisure. It's all just going to spray me in the face. So I couldn't think of a better way to represent a subscribe in Factorio, but then I discovered cheats. So with some cheat commands in Factorio, you can get access to a few different items. And one of those new items is this little loader contraption here. And what this is going to do basically is anytime something is coming down one of these conveyor belts, it's just going to push it directly into a chest. And this is another cheat item I have, this infinity chest, which basically is just never going to fill up, and I can get infinite free items for free from it. So these will work really great for our analogies moving forward. Okay, so let's get into the first operator. We're going to talk about a map operator. So both the map and filter operators in RxJS are very similar to mapping and filtering arrays. When we map an array, we run all the elements in the array through a mapping function that modifies it in some way. So you might have an array that is 1 through 10, and we run a mapping function that adds 1 to each of those elements, and so now it's going to have the numbers 2 through to 11. And so we do the same for mapping an observable stream, except our mapping function will be used for every data emission from the stream over time. So this is a continuous process, unlike mapping an array, which just happens all at once, and then it's done. So let's turn on our little example here. I'm just going to pull some items out of the chest. We have some iron ore coming out. And this furnace here is representing our mapping function. And so what it's doing basically is converting this iron ore into iron plates by smelting it. And then we have what is our subscribe down here, which is getting those iron plates. So we originally have a stream of iron ore, but the stream we end up with is a stream of iron plates. Now, the longer I leave this on, we do start to see some problems with the analogy. It starts breaking down because this thing isn't fast enough to keep up with all the iron ore, and it's starting to stack up, which absolutely wouldn't happen in an RxJS stream. And another problem with the analogy here, and one that we will have with the filter example as well, and really most examples we will do, is that our mapping function here doesn't actually modify the stream directly, it creates a new stream. So here you can see we're pulling data off of this stream and putting it onto this new one. But in the process, we're modifying this stream. All of the iron ore here is getting taken off the stream. But if we wanted to, we could actually subscribe to both of these streams, and all of the original data would still be on this stream unchanged, and we could subscribe to the new stream as well. So really, this should be duplicating these iron ores over to the mapping function rather than taking them. But again, a lot of these analogies do break down a little bit in Factorio, but hopefully it is still helpful. And another point here is that you typically wouldn't subscribe to this initial stream either. If you're piping a map operator onto the stream, you're probably interested only in this new stream that's being created, not the old stream, but it probably is important to know that. Okay, so let's move on to the filter example now. So the concepts here are very similar to what we discussed for the map operator, except this time, rather than changing the values that are emitted from the stream, our new stream only emits a subset of the data from the initial stream. So in this case, our filter function allows us to return either true or false. If we return true, the item is allowed onto the new stream. If we return false, it is not allowed. So in this example, we're only allowing the blue items onto this new stream. And again, this has the same problem as the map example. We wouldn't be taking the items off of this stream and putting it onto a new stream. We would be duplicating them. So this original stream would remain unchanged, and then we'd have a new stream with only blue items on it. And now the final example we are going to look at is a merge. So a merge will merge multiple streams into a single stream. So you can see here we have 3 different streams here. We have a stream emitting red items, a stream emitting green items, and a stream emitting purple items. And then all of these are being combined onto this single stream, which we are then subscribing to. And so rather than having to subscribe to these 3 streams individually, we just subscribe once and we get all of the data emissions. Now there is also another slight issue with this analogy, and that is that when we merge a stream, the data emissions are going to appear in the merged stream as they appeared in the original streams. So if we look at the order here, we can see we've got purple, green, red, purple, green, red, purple, green, red. We would get those data emissions in this merge stream in that order. So over here, we would get purple, green, red, exactly when they appeared. But in the example I've set up here, the streams that are sort of further back horizontally this way, they have this extra travel time on the conveyor belt. So we might actually get things a little bit out of order. So this is a pretty good example otherwise, but just keep in mind that that order will remain intact when you merge streams. Now, one more thing I want to mention before we go is the mergeMap operator, which we are not going to take a look at in this video. But the reason I want to bring it up is that we have covered both the merge operator and a map operator. So you might assume that a mergeMap operator would be some kind of combination of both of those things. However, that is not the case. If we wanted to merge then map, we could just simply pipe both of these operators. We could do a merge, and then we could add a map operator onto the merge stream. So what a merge map actually does is a bit counterintuitive, I think. The idea is that we can subscribe to a new observable stream every time the stream emits a value. This creates observable subscriptions inside of our observable stream, which are referred to as inner observables. So we'll be doing something like this. Say we're working with this stream here, and we want to do a merge map on this. We might set a merge map to subscribe to some other stream every time we get a data emission. So you can see here we've got a green, red, purple, green, red, purple, green, red, purple. Every single time we get one of these data emissions, we're going to subscribe to a new stream. So if we just count these bottles going past here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At this point, we have 10 subscriptions to observable streams, and it's just going to keep going for every single data emission that we get. So what is actually happening with a merge map is actually quite different to what is going to be happening with a merge and a map. So I will go into merge map in more detail in the next video. I just wanted to include this little extra bit in this video to get the point across that a merge map isn't a merge and a map. So I'm going to try to set up an example of a switch map, merge map, and concat map in the next video, which are all quite similar, and they're all quite commonly used as well, especially a switch map. Now, I haven't actually thought about how I might do these in Factorio yet, but I'll see what I can come up with. Okay, I hope you enjoyed this video. Let me know what you think of these analogies specifically, and if you sort of see any other types of holes in the examples I'm using. And if you did enjoy the video, please feel free to leave a like and subscribe, and I will see you in the next video.